Hi guys, we're going to do some air pressure demonstrations today to go along with chapter 14, or just for fun. I wish I could do this with you guys in person, but this is the best we can do during this COVID-19 stuff. Anyway, I'm going to start off with this little balloon here. And it is sealed, but there's just not very much air in it. You can see if I squeeze it though, I can get it to, prove to you that it's sealed. I'm going to put it in what's called a bell jar, okay? This doesn't seal at all, this just sets in place. Okay, but it's eventually going to seal. I'm going to remove the air from it, okay? By removing the air from inside of this container, I'm creating a low pressure environment inside, okay? Remember, high pressure always wants to go to low pressure, so two things are going to happen. Kind of make some predictions to yourself. If this becomes lower pressure inside, what's going to happen to the balloon? But something's going to happen to this as well. Now I have to do it really steady, because if I move the jar at all, I allow air to go right back in there. All right, I think we've got it. Okay, watch the balloon. There we go. Okay, what's happening to the balloon? Oh my goodness, it looks like it's expanding. Yep, it is. All right, that's about all I can get out. Okay, but watch what else happens. This is totally stuck in place now. I cannot get this off. I'd probably break a fingernail if I tried to pull this off, okay? So, as I created a low pressure environment inside, the high pressure outside is trying to get in there. And so it's actually pushing this cover in place, okay? It's not being sucked into place because science doesn't suck, okay? The balloon had its own pressure, and that pressure was pretty equal to the pressure outside of it. But now that it's in a much lower pressure environment, that higher pressure inside of the balloon is trying to get out to the lower pressure. And so the air inside of the balloon is expanding because it wants to get to that lower pressure. And so it actually looks like it's blowing up, okay? Now, as I release this little valve, immediately it's going to go back to normal, okay? Watch. There we go. Okay, the balloon's back to how it was, and the pressure is stable. All right? All right, let's look at a couple more. All right, I've got this rubber mat here, right? It's rubber mat, no big deal, right? And yet, what? I can't lift it, okay? Watch what happens when I put it on this stool. Okay, so there we go. Again, if I slide it, it comes up, no problem. Or if I pick it up by a corner, no problem. But if I put it flat, I could literally lift up the stool. What? All right, remember how I told you air has mass? The weight of the air is pushing down on this mat. It's pushing down so much, I can lift this stool, okay? It's also a second thing happening. When I drop this in place, it's kind of pushing the air away from underneath it, kind of creating a low pressure environment. But because it's flat down on a surface, like over here, the air can't push in both directions, okay? If I pick it up by a corner, now the air can push underneath as well, and it's totally light, okay? If I don't let any air get underneath it, it's super stuck because of the weight of the air. Wow, it's like a magic trick. All right, that's how suction cups work too. So I've got this suction cup. I'm going to push it down, and what that does is it removes the air from underneath it, creating a lower pressure, okay? It's not really going to stick to this table well, so I'll put two together, all right? Push them together, and that creates low pressure inside, okay? So the higher pressure outside is pushing on both of these, so that, they really stick together. They're not sucking to each other, because science doesn't suck. They're getting pushed together. Okay, super hard. If I release the little knobs here, I automatically let the air pressure stabilize and they come apart super easy. That's how suction cups work. All right, let's do another one. I think I've done this one for you guys before, but I'm gonna do it again because I like it. All right, my magic jar here. I'm gonna pour water into the jar. Okay, I can pour the water out of the jar. Okay. Let me fill it all the way up. All right, it's filled all the way up. I'm going to use the lid just to help me get it upside down. Okay, and then I'm going to take the lid off. Watch what happens. What? If I tip it, it pours out, okay? Okay, now, if you remember me doing this before, you remember that there is a little bit of a trick. There's a screen on the jar, okay? The screen does something, but the air pressure, okay, because the air pressure is pushing all around us, the air pressure is actually pushing up under this jar and it's helping to keep the water inside, okay? But the properties of water is very sticky. Water is known as a polar molecule, meaning it's slightly charged, and so the molecules of water stick to each other. We've talked about that. And if you look real close here, you can see that the little squares in between the screen are filled with water, okay? Because the water is real sticky and it's hanging on. So because of that, it kind of forms this imaginary wall that keeps the water in. So between the sticky nature of water and the air pressure pushing up onto the bottom, I can do what looks like a magic trick, okay? All right, one more for you guys. All right, get my balloon here. I'm gonna get this balloon to go into the jar without me touching it. With fire. All right. So what does fire need to burn? It needs oxygen, okay? So there is air inside of this jar. It's the same pressure as the outside. I could put a lid on it. This balloon acts kind of like a lid, and it's still the same, okay? But what I'm gonna do is I'm gonna put something in here that's burning. And so it's gonna burn up the oxygen inside. Well, as that oxygen is being removed, kind of like that bell jar in the balloon before, the pressure is gonna get a lot lower inside, okay? Well, low pressure inside, higher pressure outside, high wants to go to low. Watch what happens. I should have done this one first after I filmed everything else. Let's hope it works. I'm just kind of gently holding it in place so it's sealed. Whoop. That was kind of cool. But did you see how it was getting pushed in? It was not getting sucked into the jar, okay? Because science doesn't suck. It was getting pushed in from the higher air pressure outside of the jar, okay? When we get back to school, I'll do that one for you in person. I hope you guys are doing well. I miss you guys. See you later.